After calculating the NPV, BCR and NK ratio for the Lahore Sialkot Motorway project by using MS Excel, now we will calculate the internal rate of return, that is IRR, for the same project. We remember this data that we have for the said project: time, cost, benefits, net benefits, discounting factor, discounted cost, discounted benefits, discounted net benefits before and after. Now we are going to use the same table, however in a more customized way. We know that IRR is all about finding that discount rate which is going to lead NPV to 0. So for that we should focus on this column, that is the column of discounting rate or discounting factor. Here the discounting rate is 12%, so we have to get rid of this because now it's not necessarily the 12% of the discount rate, 12% discount rate. Now this is the formula in which I wrote some other value, but I think I should choose a certain value or in a certain cell which I have highlighted with the heading of discount rate, and if I put the discount rate here, it should borrow the value and it should use it in all of these cells. In this way it will be easier for me to calculate the discounting factor for a number of cells, and I'll have to type the discounting factor only once here. So let me just put the value here. Before I put the value, I should change the format, and the cell format should be percentage here. I have already chosen that. I can make it to up to 4 decimal places because I am in search of precision here, and for that I am increasing the decimal places up to 4. So the format is correct, and I'm going to put for example 12% here just for the sake of beginning the calculations. And then we have the discounting factor table in which I should fix this cell here, the cell which is B1. So I enter it, all other values they are the same, that is the constant 1, and E2, that is the cell of time, it is the same. So I enter it and the discounting factor comes to this, and I paste it. But this is 1 for all these years. This is definitely not something we need. So we should check the problem here. So when I edit this cell, I see that the discount rate is now in this cell because we didn't fix this cell, that is B1, so we better fix it. If I choose the final cell, editing the formula, I find that this has chosen a cell which is having no value, so there is no discounting. This is why the answer is not a factor, it is equal to 1. So from this I can choose this, I can press F4. When I do so, it fixes the cell. Now it is a fixed cell. I can copy paste the formula in all of these cells. Now it is updated. I can check in the second last cell, for example. Now you see that time is in 9 and the cell of the discounting factor is the same and it is fixed. This is what we wanted. Now we have the certain situation. Now we can calculate the discounted net benefits here simply by multiplying these two. This is something we have done before. I can choose either of these two columns, the answer will be the same. Discounted net benefits and discounted net cost. Let me use this column, the first column of the discounted net benefits. Its sum is equal to 41.2344. At 12% it was the same, but now let me increase the discount rate and see how it decreases, because I want this to be equal to 0. So here instead of 12% I can write 25%. So you see the discount, the NPV has come down to 2, which is a good thing for us. And then we know that we have to further increase it. So let's increase it to 27%. Now it becomes negative. So it means it is somewhere in the middle of the two. That is, it is 27 and 25, between which the NPV will become 0. So let's decrease it a little bit, the discounting factor, because the NPV is now 0. Let me try 26. 26 keeps it positive, but still it is not 0. I have to make 8 5 or 8 1 8, approximately at least 2 of them 0, so that becomes closer to 0. So let's make it 26.5. It becomes closer to 0.10 at least. So 26.6 is something I can try. Now it becomes negative. It means that it is between 26.5 and 26.6. So between these two it will be half of it, the average of it, that is 0.55. Now you see one of the decimal places has become 0, which is definitely close to 0. We can further improve it. So if I slightly increase the discount rate, it will become 0.00, and this is something that I want. So let me further increase it slightly. Instead of 0.55, I can write it 0.7, and you see that now it is now up to 2 decimal places 0. So we can experiment this, and we can get more decimal places as 0. For example, 0.58, but now it turned negative. So I will try to make it not 0.7, not 0.57, neither 0.58. I'll make it 0.575. So half of it is added, and still it is negative. So I can decrease it like 0.574. It is still having that negative sign. Negative sign is something we don't want. We don't need negative sign. So we decrease it a little bit so that NPV increases and becomes positive. Still it's not working. So 0.7572, 0.7571, and still it isn't working. So I can try this combination of digits, but it seems as if this is too much and it's making it negative. So I can try this combination of digits, and then I can try 3 3 5. It still remains 0. So I can try 6 5 5. It becomes 0 up to 2 decimal places. Then I can try 4 5. It's not going in that direction. 5 7 might do the trick. 5 8, 5 9, 6 or 7, 8. So now I have experimented with a number of values, and I think that I can be complacent with this, because this is now, though it's with a negative sign, but it's having this 3 or 4 decimal places to in the form of 0. And you can see the effect on the BCR as well. Now BCR is equal to 1, and it is 1 up, and the decimal places are 0 up to 4 decimal places. It means that the discounted benefits and the discounted costs are now approximately equal to each other. Their sums, here you can see their sums are now equal. This is actually indicating that NPV has actually turned to 0, because at NPV 0, BCR is equal to 1, NK ratio is equal to 1, and definitely the discount rate becomes IRR. But this negative sign still bothers us. So without further experimenting, we can try to calculate the internal rate of return. Now I have updated this by using this value, which is 0.57, and now you can see that the negative sign is not there. We have to do a little bit of experimentation. However, formula will come our way and will solve our problem. NPV now is equal to 0, and BCR is 1, and so is the NKR ratio. And IRR formula is something that we can do in order to get the precise answer. For that, we simply enter equal sign and then we write IRR. When we do so, the formula appears, the tooltip for it. It says that we have to choose the values should be of the discounted net, the undiscounted net benefits. We don't have to discount it, and once we select this array, this guess tooltip is required. It is required on an optional basis because it is in the block brackets or square brackets. Therefore we are free not to enter these values. If we want to, we can. So we can now close the parenthesis, and simply by choosing the net benefits column, we can calculate the IRR using this formula. And as I enter this, I get this answer is definitely more reliable because it comes with the precision, and we can extend its precision by going into the format cell and extending the number of the decimal places. Here you can see the decimal places are extended to more realistic. I think 6 would be enough here. And now you can see the one of the most precise values of the discounting rate, where the NPV will be equal to 0. It is 26.570939. So it is very much precise now. So this is the liberty of using the IRR function in Excel, that we can find the IRR to a very good extent of precision. This is how we can calculate the IRR and make sense of it by comparing it with the opportunity cost of capital. And all these values are showing that it is that point where NPV is equal to 0, BCR and NKR, they are equal to 1. It is written that these are feasible projects. This is not the best thing to write right now. We will explain how we can interpret in another video, but right now we have found these 4 measures of project worth that are discounted in nature. Thank you.